Pythagorean theorem is an equation that shows the relationship between the legs and hypotenuse of a right triangle. It has been used for thousands of years to measure distance, help build things, make accurate drawings, and tell how tall something is. It is still used today and is an important mathematical equation. Even though it has been around for a very, very long time, there was a mathematician named Pythagoras who was the first person to actually prove it existed. But before we talk about the Pythagorean theorem, let's take a look at right triangles.
Oh well, let's see. A right triangle has one angle that equals 90 degrees. It has two legs and a hippopotamus. Oh, wait. I mean hypotenuse, which is the biggest side. It's like a hippopotamus because it's big, but it's called a hypotenuse. If you look closely, you'll see the hypotenuse is opposite of the right angle. Usually, a right triangle is marked with the letters A, B, and C, where A and B represent the legs, and C is the hypotenuse. This helps us write the Pythagorean theorem.
If we use the letters A and B to represent the legs, and C to represent the hypotenuse, we can write an equation that looks like this. A squared plus B squared equals C squared. This means that if we square the length of A and square the length of B and then add them together, they will equal the square of the length of C. The Pythagorean theorem.
So now you got this equation. But how do you use it? And what do you use it for? Well, the Pythagorean theorem is great for checking to see if a triangle is a right triangle. This helps us see whether or not two lines are perpendicular, or 90 degrees. Later on, when you learn some more math, you can use this information to find the measurements of other angles and distances around that 90-degree angle. More math? But that's later on, so don't panic. For now, let's just prove whether or not a triangle is a right triangle.
So you got this triangle with sides 6, 8, and 10. And you're not 100% sure it's a right triangle. Well, you can use the Pythagorean theorem to prove whether or not it is. All you do is square the legs and add them together. If they equal the square of the hypotenuse, then it's a right triangle. Remember, the legs are the two shorter sides, and the hypotenuse is the longest one. It's across from the right angle, or at least the angle we think is 90 degrees, so the equation will look like this. 8 squared equals 8 times 8, 6 squared equals 6 times 6, and 10 squared equals 10 times 10. 8 times 8 equals 64, 6 times 6 equals 36, and 10 times 10 equals 100. 64 plus 36 equals 100. Oh, so this is definitely a right triangle. Take a look at this triangle. You have two short sides of 7 centimeters and 9 centimeters, and one long side of 12 centimeters. If you plug this into the Pythagorean theorem, you get this. 9 squared is 9 times 9, 7 squared is 7 times 7, and 12 squared is 12 times 12. 9 times 9 is 81, 7 times 7 is 49, and 12 times 12 is 144. And 81 plus 49 is 130. Uh-oh.
130 does not equal 144, so it is not a right triangle.
The Pythagorean theorem is a theorem, which means that someone has actually proved it is true. And since it has been around for a very long time, many different people have created various ways to show it exists. The one I like is this one. If you watch carefully, you can see that a squared plus b squared equals c squared. But let's take a closer look. Here is a square which has 4 right triangles that are the exact same size. these triangles create another square inside. This yellow square has 4 equal sides. We'll call each one C, which are also the hypotenuses of the 4 right triangles. To find the area of a square, we multiply 2 of the sides, or just square one of them, since they're all the same. So the yellow area is C squared. Let's take a look at the 4 triangles. Remember, they are all the same size. If we mark all their legs A and B, it will get a little confusing, so let's just mark these 2. Now, we're going to rotate 2 of the triangles without changing their shape or size. The first one will create a new square with 4 equal sides of A, and the other one will create another new square with 4 equal sides of B. I told you before, the area of the square can be found by squaring one side. So we have A squared and B squared for those 2 squares. Let's take a look at the original example. Do you see how the area of the outer square and the 4 triangles never changes? Which means the area of the black square never changes. It only looks different. So A squared plus B squared must equal C squared, the Pythagorean theorem.
So we use the Pythagorean theorem to prove if a triangle is a right triangle. But what else can it do?
There's a giant fire in the city, and Joe the fireman needs to save a woman on the 2nd floor of a burning building.
Help me! Help me!
She is 35 feet up, but Joe has to place the ladder 12 feet away from the building. How long does this ladder have to be?
Help me! Help me!
Since the building and ground make a 90-degree angle, he can use the Pythagorean theorem to calculate how long his ladder needs to be. In other words, he can find the length of a missing side of a right triangle.
Help me! Help me!
She is 35 feet up, and the ladder is 12 feet away from the building. Both of these amounts are the legs, so you'll have to find the hypotenuse. The equation will look like this. 12 squared plus 35 squared equals C squared. Well, 12 squared equals 144, and 35 squared equals 1,225. You add those together, you get 1,369. Well, since it's C squared, you'll have to take the square root of 1,369, which equals 37. So the ladder has to be 37 feet long.
Help me! Help me! You saved me! You're my hero!
Check this one out. We have a right triangle with one leg of 13 centimeters and a hypotenuse of 16 centimeters. As you can see, we do not know the length of one of the legs, but we do have the Pythagorean theorem to help us. The equation will look like this. 13 squared equals 169, and 16 squared equals 256. If we use our algebra skills, we can move the 169 to the other side and get 87. But 87's not a perfect square. It's between 81 and 100. But if you think about it, it's closer to 81. So the missing leg is the square root of 87, or about 9, or more exact, about 9.3. Or if you want to be silly, it's about 9.327379053088815 ... which is just an irrational number.
Well, I hope you liked the show. And remember, math is everywhere and anywhere. Or is it anywhere and everywhere? Anyway, I hope we helped.